This video is on exponential derivatives, so in this video you'll learn the following things. We'll learn how to take the derivative of e to the x. We'll learn how to take the derivative of a to the x, where a is some other constant. We'll learn how to take the derivative of, wait for it, x to the x, and functions like this, where it's a function to a different function, not just a constant to a function, or, in the case of the power rule, a function to a constant. But yeah, that's a good start. Let's go with it. Let's say you're bored and you're wondering to yourself, what's the derivative of e to the x? Well, if you don't give up right away, you can think a little bit and say, well, let's start with this. We'll start with y equals e to the x. And hey, I just learned this cool new trick. It's called logarithmic differentiation. So what we're going to do is we're going to take the natural log of both sides. Natural log of y equals natural log of e to the x. And now you're going to be a little bit clever, and you're going to bring the x down in front using your properties of logs. Very nice. So we have this. We have the natural log of y equals x times the natural log of e. Oh, natural log of e. That's something, because it's like the log base e of e. And if you remember your properties of logs, that's just 1. Ah, very nice. And so we get that the natural log of y equals x. Great. Now what? Oh, right, I have to do the differentiation part. So I take the derivative of both sides. The derivative of the derivative of natural log of y is 1 over y times y prime, and the derivative of x is 1. Keep in mind what we're trying to do. We started with y equals e to the x. I'm looking for y prime. Oh, there it is. Great, so I'm going to solve for y prime. Y prime equals y, because I multiply the y over. Y, you say? It just does. That's okay. But what was y? Oh, y was e to the x. So y prime is also e to the x. So this means that, yes, wait for it. Yeah, the derivative of e to the x is simply e to the x. It's kind of my favorite function because the slope, the y value at every single point is like the slope at every single point. It's kind of cool. Like, just kind of think about that for a second. Better yet, I'll force you to think about it for a second. Haha. Here's the graph of y equals e to the x, and just kind of notice, hey, the slope here looks like it's positive, you know. Oh, hey, it's a y value that's positive. As I keep going this way, notice how the slope gets closer and closer to 0, just like the function gets closer and closer to 0. And as I go along this way, notice how the slope gets bigger and bigger and bigger, just like the function getting bigger and bigger and bigger. And in fact, e to the x is special because it's the y value of e to the x is its derivative at every single point. Very cool. So we learned this fun new fact. Here's another cool fact. Let's say I wanted to take the derivative of a to the x, where a is some constant that's not e. Well, it kind of looks like that, right? E to the x equals, the derivative of e to the x equals the e to the x. So the derivative of a to the x is, guess what? It's going to be a to the x, but wait, there's more, times the natural log of a. And this simply comes from some logarithmic properties that you don't have to know. But if you memorize the fact that the derivative of a to the x is a to the x natural log of a, you'll be good. And actually, this rule kind of works for e to the x as well. If I multiply this by the natural log of e, that's the same thing, because remember the natural log of e is 1, so it's still just natural log of e. It's sort of like the chain rule, but it's not. This is not the chain rule. It's sort of like the chain rule, but it's not the chain rule. So you have to watch out for that. Let's do some basic practice. The derivative of e to the stuff. Oh, e to the stuff, you say. Well, it's going to work the same. Guess what? We're going to have e to the stuff, and then you're going to have to chain rule it. Notice that the chain rule is going to be multiplied, so it's like kind of down on the level of e, not with the exponent, and I'm just going to multiply by negative 3. Simplify, negative 3 e to the negative 3x. Great. Let's say I take the derivative of 2 to the sine of x. Why would that be a function? I don't know, but we'll go with it. So I have 2 to the stuff. So my derivative is, guess what? 2 to the stuff. Now, this is not just e, so I need a natural log of 2. That's not the chain rule. This is the chain rule. I do chain rule with sine, and I get cosine. So this is my final answer, and that's completely simplified. 2 to the sine x times natural log of 2 times cosine of x is my final answer. And yes, e to the x plays nicely with all the other rules, such as the product rule. So if I have e to the negative x times sine of x, that's f times g. So I'm going to do f prime g plus g prime f. Let's do it. F prime is the derivative of e to the negative x, so it's going to be e to the negative x, e to the stuff, times chain rule. The derivative of negative x is negative 1, so I'm going to multiply this by negative 1, which basically means I'm just sticking a negative out in front, times g is sine of x, plus g prime is the derivative of sine, which is cosine of x, times f, which is e to the x, and e to the negative x, and that is your answer. So at this point, we sort of know how to do almost every form of derivatives with exponents. For example, if I have the derivative of e to the e, this is a constant to another constant. It's like taking the derivative of 3 to the third, or 5 to the fifth. It's a constant, so its derivative will be 0. I can also take the derivative of x to the e. Okay, now this is x to a power, so this is just my power rule. I'm going to bring e down in front, x, and then to the e minus 1. That's it. That's the power rule. I can also now take the derivative of e to the x. So if I have a constant to a variable or a constant to a function, this is just e to the x. Chain rule and stuff applies when applicable. The last type of function that falls in this category is the derivative of x to the x, which is a really weird function when you think about it. But how do we do this? Let's find out. Let's say you get bored one day and you're like, how do I take the derivative of y equals x to the x? Well, oh hey, I just learned a cool new trick. It's called logarithmic differentiation. So what I'm going to do is I'm going to take the natural log of both sides. So natural log of y equals the natural log of x to the x. Ooh, using properties of logs, I'm going to bring that x down in front. Like that. This is not the power rule, it's a log rule. So remember that. Yeah. So I'm going to bring it down in front, and I'll have x times the natural log of x. That's a lot nicer, isn't it? And now I will take the derivative using implicit differentiation. The derivative of the natural log of y is 1 over y times y prime. The derivative of this, I have x times natural log of x, so I have to use the product rule. So I have f times g, f prime is 1, so f prime is 1, times g is just natural log, natural log of x, plus f, which is x, times g prime. The derivative of natural log is 1 over x. Let me simplify this. I'll have 1 over y prime equals 1 times natural log of x, which is simply natural log of x, plus x over x, which is 1. Almost done. Now I just have to solve for y prime. So I'm going to multiply y over, so I'll have y times natural log of x plus 1. And then remember, from way back in the beginning, that y was simply x to the x. So this derivative, I will have y prime equals x to the x times the natural log of x plus 1. There it is. Okay, so that's a kind of funky derivative, but it's kind of cool. Using this, you can take the derivative of anything of the form f of x to the g of x, because basically in this step you'll do some product rule and it'll all work out and be fine.